Hello friends, this is the PVLate in software. This software is used for designing of pressure vessel, heat exchangers. Those who are belongs to the or those who want to make their career in static equipment design in oil and gas sector or many fields. There are much more many fields. These static equipments are used. So this is the basic software is used. So when you will open the PVLate software, this is the interface you will going to see. The first, there is a file section is here, uh, and this is the very common area. It's very common in every phase like Word document or PowerPoint. You will find the new, open, and save tab. This is very common and same. Then there you will find the element tab. In that there are set of elements like cylinder, dish head, cone, flanges, different types of dish heads, then square. uh, then there will be the details analysis. These detail parts are there. We will see one by one. So we will start with the very basic, first of all, tour of this software, the basic elements of the software. Uh, so suppose we have to start a design of a vessel. We will start with a very common element, a vessel. So if suppose I have to decide start a vessel design, so first of all we need to do some settings in this software. So first of all we need to find out the what will be the unit of this our design. So we can change unit from here. In this section you will find the units. So based on your data sheet you can find out the whether it is in inches, in English unit, or in so for ease I will choose conversion. This kind of table unit will open. You just need to press the OK. Then suppose this your there your vessel is a horizontal vessel. So first element, or before doing this one, you can see these unit sections. There is a details, their input, output, utility area, then auxiliary. We will go one by one to the each, but very first, before this one also, there is a design constraint. This tab here, configuration parameter we need to set before starting of that any design. So we already check the unit. Then here the division. So suppose I have to set a configuration parameter. So when you click in configuration parameter from auxiliary, or you can go from the tools also. In the tools, you can go like this and set configuration parameter like this. You can open here. So you will find job specific settings, nozzle analysis, ASME options, impact test requirement, weld seam, DFX, default values, save options. So save option, we can enable auto save option so that our file will be saved automatically. So I will keep here 5 minutes and perform silently background save. So it will save automatically in background. So this setting also very important because sometimes the pivot get crashed. So in order to save our work, we can do this auto settings so that it will be saved automatically. Then there is a AI setting. This one I never used. So let's see. Uh, so first of all, I will choose the here in this sheet. Most of the settings are common, and we will not going to touch this one. Then nozzle analysis. In nozzle analysis, most some in fabricator they are using MAWP plus static head. Some are using design pressure plus static head. Some are using overall MAWP. So based on your requirement, you can select that. So I will choose the MAWP plus static head to the nozzle, and then nozzle sorting option is there by name, by ascending, descending. So I will keep as default, and here these settings also will keep as it is. Then we'll go with the ASME option. In ASME option we need to choose that which code we will going to use, like which year edition of code. So now I will keep as current. And if your vessel is like pre 99, before 99, it's a, suppose you are working on old vessel, so you can choose this option also for pre 99 case only. For new vessel, it is not required to check. Okay, this one, there are some code cases, we'll keep as it is. Then use of metric material database. So we'll keep no, we'll keep as it is. Material database selection, as our code of construction is current, we will keep the material database also current. Here there are some options. I will keep this MDMT option as a table value. Okay, then here there will be no change. So these are some basic settings we can do. So I will keep place this one. Okay, so now the basic setting is done. So I will add first my component as a dish head. So when you will click a dish head, it will open like in vertical section, like it's going from bottom to top. So if suppose I have to make a horizontal dish head, then I need to turn on this. Means like in this way we need a dish head. So what I will do, there is an option in the utility. Now these options are active in detail in input output utility. These options now it active. Before there is no, these are options are there, but it is inactive. So here also by adding one element, this design code is also active. So if your vessel is division 1, division 2, PD5 5500, EN13445, so we will select our design code as division 1. So now this one is okay. So if suppose I have to make a horizontal, but my dish head is like in this way, so there is an option to flip this one, flip the element orientation. So if I will click this flip, so now this is correct way. In this way only I want. So though then I will make my name of this dish head like left dish, and then we can change, we can write that it is elliptical. Suppose I will keep this IDS 1500. Then straight face SF is that straight plane face of this one, will keep 50 as it is. Then thickness, suppose my dish head thickness, this side always has a minimum and nominal thickness. Suppose I have this side of a 7 mm thickness and nominal is 8 mm thickness. My corrosion allowance will be 3.2. Suppose I am just making this one. And then external corrosion allowance is 0. Wind multiplier normally we keep as 1.2 only. Material. So material we can, here by default it is 516 grade 70. Suppose I have a different material. So you can type directly. Suppose you have a plate, stainless steel material, so you can type like 340. Then you can select a material here, whether it is 304, 304L, 316, by simply typing the material. And there is a one in the bottom, one filter bar is there, so you can search also by everything material composition UNS number. So you can try type a material and there directly search. So this is the option we are getting. Okay, so here this material is 516 grade 70 by default. So suppose 516 grade 70 material is there, but you want to make it like it's normalized or impact tested or post weld heat treatment. So this kind of information also we need to enter. So first we can click here in this option in the arrow and go to the property. Once you click on the property, you will find that the various properties like allowable stresses in ambient operating hydro test, condition, P number, its curve, UCC curve. If it is impact tested, we have to select the curve D or simply select the normalized. It will automatically come. If it is not normalized, you click on this one, so it will automatically select the curve B. So now I am selecting the normal, not normalized, and okay. Then the longitudinal seam efficiency, it is depend on the RT requirement. So it is, suppose it is seamless and we are having in job assumed as a joint efficiency 1. If you have a spot radiograph, you can select a 0.85 here. Now I have to keep the design pressure. Suppose I have a 400 kilopascal of design pressure and temperature of around 100 degrees centigrade. Okay. Then external pressure I will keep as 0, no external pressure, and then here also 0, no external pressure. So under this design condition, as this is a simple vessel, so this information, instead of typing every time this information, I will this simply here in the design constant option, I can type simply same information like 400 kilopascal design pressure, external pressure is 0, and here design temperature is 100, external temperature is 0, And in the design constraint, there is other options like we can define a user defined MWP, but we will keep it as checked by this calculation. Then here is a soft test pressure. You'll keep as UG99B. Then hydro test allowable 90% of field. You will take tick this one. User defined test pressure no. Horizontal position will be horizontal only. Field test pressure will not going to tick this one. Suppose our MDMT is 0, so we can keep here MDMT. No UG20F exemptions, we'll tick this one. Then RT requirement, suppose our vessel is RT4. Suppose it is spot radiograph, then we can select the RT3. But here in the column we selected as RT1, so we'll keep is RT1. User longitudinal stresses, you can keep check this one. And there is no other options, no need to select other options for simple vessels. So this is the basic constraint. Design constraint tab we can fill for in case of vessel, so that our all design parameter will automatically it will get to other elements. So this is our first element, dish head. Then I will add one shell portion here in the center. So I will just name it as a shell. And see, the diameter is automatically it's got the same diameter 1500. So this is the shell. First I will save this item to the heat exchanger vessel. I will write the name as vessel 1. Okay, so that we cannot we will not lose this item. So this is the shell. So thickness I will keep as both is same, because cell usually have same thickness. And then corrosion alarm is same, material will be same. This temperature it's automatically came from this design constant. Okay, so I'll keep this length as 2500. Okay, so 1500 by 2500, this is the shell element. If suppose I have to define this radio this long sim position, so here you need to select it. If you see the three dot, you just click it, and here in the longitudinal wheel sim data, you can select a number of sim here in the cylinder. I will type 1, and its location I will type as 45 degree. Second one is not there, so no need to. If you not click this one, suppose I will keep as it is, so only one sim will come, and it is 45 degree in this way. Suppose if you want to also decide that how the orientation of this means, how you will calculate like where is the north. So this settings also there in the set configuration. You can, in the default value, you can see here, as we can keep click as here in the default value in the bottom you will find zero angle direction position. We can keep north as a 0, and it's a clockwise rotation. So north and clockwise we can set, so it will automatically take take the values. So now we'll uh, weld sim location, it's 45, we'll keep. Okay, so now this is the 45. If you see like this, so 0 here, 45, 90, 180, 270. So the last element now we'll add here as this one, dish head. So this is the closing dish head. So we'll write as right dish head, and this data will be copied directly. If you are adding this data in the design constraint tab, it will get directly here transmitted. So this is the basic data. So our basic body of a shell vessel is ready. So now if I have to add a water inside fluid, so here is the tab in the detail section, this water like element, you can see liquid input. Just click on the liquid input. You can type the specific gravity. Suppose I have water, so specific gravity will be 1. I will keep as a full, fill the element, and okay, press OK. So you can see here liquid is full. Here in the second portion, if again I will select the same, I will click OK. Again, I will repeat the same procedure, full, fill the element, OK. So now you can see liquid 10, 20, 30 means 3 element. The element 1 is start from 10 to 20, second is 20 to 30, third one is 30 to 40. In this way, the element, this complete liquid is filled inside the vessel. Suppose now we make the vessel, but I have to check whether it is okay or not for this particular pressure. Only in the internal pressure condition, you can see the result here in the bottom line section. Here the value TR is here. So TR is 5.45 in the bottom. Uh, and here MAWP you can see. So if it is if I will increase here instead of 400 to 4000, to see here the values will change. Here required temp thickness is 25. Here MAWP also failing, everything is failing. The failure is reported as a in the red color here in this job in PVLIT software. So wherever there is a red color, if you find, it means there is a chances of failure. So you need to analyze the report. So once you make this one, we completed very basic model of a vessel. So now I have to run this software, run this one design model. So for run, there is an option in analyze tab. In analyze tab, this two people running this tab, you need to just click on one time. It will take just moment in within 10-20 second. It will analyze. In this way you will find a report. So in this report, by going in the vessel design summary, you can find out the basic detailed calculation, in which we not selected now wind and seismic, but maybe in the upcoming classes we will see how to enter the wind and seismic data based on the wind design code. You can see the maximum allowable pressure is calculated for that particular input design pressure. Design pressure is 400, design temperature is 100 degrees centigrade, external design temperature is 0, MAWP is 684.5, shop test pressure is also calculated here. MDMT is 0 degree Fahrenheit, centigrade, and our computed MDMT is -29. Our elements are only two. Now we didn't add any support or nozzles, so that's why it's very simple. So it is just a preliminary introductory. Now slowly we will going to increase learn the in the next session. Maybe we will learn how to add the nozzles, manways, and the supports in the vessel. So this is the part. In that you can see the left dish head design calculation. So it's look like this. In this way you can find the elliptical design head informations are there, internal corrosion. You can see UG81 data, and here is the internal pressure calculation for dish head as per UG 32 for the dish head. For shell, there's the calculation as per UG 27. Percentage elongation, you need to check this percentage elongation in case of carbon steel. When if it is more than 5%, then it's require a stress leaving. For the shade also you need to check this thicknesses, and here the fiber elongation, it is within the limit, means less than 5%, then it's okay. No further post forming heat treatment is required. But if it is more than 5%, then it's post forming heat treatment is required. So here this shop test calculation is there as per UG 99B, 99B 35, 99C. So these are the different clauses of hydro test, and its values are here. So our governing is UG 99B. Here we will take test pressure as per UG 99B is calculated 1.3 times of MAWP into stress ratio. For stress ratio, it is only 1 for us because it's a design temperature is lower. In case of higher design temperature, it might be more. So based on that, it's changing. Second is the external design pressure calculation. Nothing is there. For weight element, yeah, external pressure calculation is done, but it's calculated that 52 kilopascal will take. When there's design, it can bear this much of pressure. For weight, detail element weights are given. So total weight we can check in the weight section here. So its field test weight is this much, 6.5 tons, and its fabricated soft weight is 1.1 ton only. So in this way, we can check the weight summaries here. Center of gravity also, it's calculating directly. It's 1300 in empty condition and operating condition liquid. So in this way, we can analyze the reports. And suppose if you want to make a report in the PDF form, so directly here generate PDF, or if you want to make it some edit section, or you want to add anything, so you can select uh, all report or maybe a part of report simply. You can select a report as a text. You can select all the reports. By selecting this one, all reports are selected, and you can click on the work document, then Word file will be generated. And if you want to only see the generate a PDF, then you can simply click on the PDF, then PDF will report will be formed. So you can save that PDF report and you can use that one for further study or analysis or to share with your client. So this is the way you can see it's a very nice report is generated by PV software. So this is the one we will do maybe another session for detailed design. This is just an introductory session. I hope you enjoyed it. So if you we will see one by one other elements also. So this is just an introductory. So thank you. Bye bye.